All right, now we're getting to the part where we're going to actually relate decimals to fractions. And I told you if you can say the decimal correctly, you can write the fraction correctly. For example, number 1, if I read this decimal, that is 6/10. So how would I write that as a fraction? Oh, I would write it as 6/10. If I were to say this decimal, 71/100, how would I write that as a fraction? 71/100. If I were to say this decimal, 429 thousandths, how would I write that as a fraction? 429 thousandths. So again, if you can correctly say the decimal and use the correct place value, you can match it with its decimal, or excuse me, with its fraction, okay? So let's look at practice. If I have this one, think about what it would look like as a fraction. If I were to say this decimal, so say this decimal in your head. I'm hoping you are saying in your head 4/10. And if you were saying 4/10 as a fraction, you should have been thinking 4/10. Okay, try this one in your head. How would you say that as a decimal using its place value? All right, you should have been saying 67/100. And as a fraction, that's how I would write it. All right, try this one. How would you say this in your head? All right, I'm hoping that you would say 549 thousandths, and then I could write it as a fraction. So notice all of these fractions are out of tenths, hundredths, or thousandths because that's our place values of our decimals, tenths, hundredths, and thousandths. All right, continuing on. This time, I can flip it where I have the fraction and I'm moving it over to the decimal. So now I'm relating a fraction to a decimal, where just a minute ago I showed you the decimal first and we wrote the fraction. You do the same thing, it's just the opposite. So if I give you the fraction 6/10, this is how I would write 6/10 as a decimal. If I give you the fraction 45/100, this is how I would write it as a decimal, 45/100. If I give you the fraction 7/1000, this is how I would write the decimal, 7/1000, because this is in my thousandths place. This is my tenths, hundredths, thousandths. If I were to write 629,000, I would have to write it 629 thousandths. Okay? Very simple, 10, 100, thousandths. Now, sometimes you're going to have fractions where your denominator is not a 10, a 100, or a 1,000. That happens, all right? And I'm going to show you what you're going to do when that does happen, because you're going to have to go back and use your equivalent fractions to make your denominator either a 10 or a 100 before, or even a 1,000 before you can convert it over to a decimal. For example, let's look at this one. Let's say you have the decimal 4/5, and I want you to change that to a decimal. Well, it's kind of hard to change 4/5 to a decimal when it's in a 5. And all of these up here were in a lovely 10, a 100, and a 1,000. So if that's the case, we have to make it that way. So I'm going to use an equivalent fraction, and I'm going to say 5 times 2 to make my 10, 4 times 2 to make my 8, and 4/5 is really the same thing as 8/10. Okay, they're equivalent. Well, now that this is an 8/10 and has tenths here, then I can easily make it a decimal. 8/10. So 4/5 is really 8/10. And again, I had to figure that out and change my 5 to a 10. All right, here's another example. If I had 3/25, well, 25ths is not in tenths, hundredths, or thousandths, but I can make it that way. I'm going to make it to a 100. So I can say 3 times 4 is 12, 25 times 4 is 100. Okay, so 3/25 is the same thing as 12/100. Well, now that I know that this is 12/100ths, I can easily make that a fraction, or excuse me, a decimal. So 3/25ths is really 12/100ths. Okay, I wanted to show these two examples because there are cases where that does happen, where they're going to show you a fraction that does not have a denominator of 10, 100, and 1,000. And before you can change it to a decimal, you have to find an equivalent fraction, okay, that would give you a 10, a 100, or a 1,000 to be able to then convert it. All right. Just like fractions are equivalent to each other, decimals can also be equivalent to each other. So I'm going to kind of go through those too. So equivalent decimals and fractions. All right. So here's an example of equivalent decimals and fractions. All right. We know that 4/10ths is the same as 40/100ths, which is the same as 400,000ths. It's the same thing for decimals. These three decimals are equivalent to each other. I've got 4/10ths, 40/100ths, 400,000ths. Okay, just like these fractions are equivalent, these decimals are equivalent. Same thing with this example. 9/10ths is really the same thing as 90/100ths, which is really the same thing as 900,000ths. Same thing with these three decimals. These three decimals are equivalent to each other. 9/10ths, 90/100ths, 900,000ths. Here's an example of where they're not, and I can use fractions and decimals to help me recognize when they are not equivalent. So examples of decimals that are not equivalent. For example, 7/10ths and 7/100ths. The reason they're not is because if I convert 7/10ths to a fraction, I'm comparing that to 7/100ths. If I want them to have the same denominator, I'm just going to change 7/10ths and times it by 10 to get 70/100ths. So 7/10ths is really 70 out of 100 compared to only 7 out of 100. So there's no way 7/10ths is the same as 7/100ths. Okay, because 7/10ths is really 70/100ths. Another example of where they're not the same is if I had 8/100ths and I was comparing that to 800/1000ths. Okay. If I were to change 8/100ths to the thousandths place, that's really 80/1000ths, and that's comparing it to 800/1000ths. Okay, so these are not equivalent to each other because 8/100ths is really 80/1000ths, and 800/1000ths is 800/1000ths. Okay, so this is a lot smaller. All right. So again, you can convert these over to fractions and have the same denominator and compare them that way to know whether or not that decimal is really equivalent to each other. All right, a visual, so you can see this. All right, so for example, if I have a 10 by 10 square, so these are worth 100, so this is out of hundredths, and I were to represent 3/10ths, but using a 100ths, that's okay. Because I know that 3/10ths is really 3/10. And if I wanted to show this out of 100, I would just times it by 10, which is really 30 out of 100. They're equivalent to each other. So 3/10ths is really 30/100ths. That's why I've shaded 30 out of 100. Same thing with this one. This one is 42/100ths. Well, there's no need for me to have to multiply to make it out of 100. It's already out of 100 because this fraction would show 42 over 100. Okay, so the only thing I would have to do here is shade 42 out of 100. That one's an easy one. This one here, I haven't shaded it. I want you to kind of think how many of these it would take. If I had 5/10ths, now this isn't out of tenths, this is out of 100ths. But if you took 5/10ths and you multiplied to where it would be out of 100, how many of these do you think you would shade? many do you think you would shade? I hope that you were thinking 50, because if you had 5/10 and you times it by 10, that now leaves you 50 out of 100. So you should have shaded 50. 5 or 10, 20, 30, 40, 50. So half of this would have been shaded. And then if you have 7/500ths, how many of these squares do you think you would shade if you had 7/500ths? Okay. Hopefully you were thinking 75, because there's no need to convert. I'm already at 75 out of 100 as a fraction. Okay, so I would just shade 75 of those. Okay. All right, and that is going to conclude our decimal place value, our fraction and decimal relationship lesson. You have an assignment that will go along with this, so you need to complete that assignment. And again, if you ever need to go back and review this video, even at home, you need to review it while you're doing your actual